What's up, y'all? This is Miss Davenport. We are going to be solving quadratics by square roots today. And so we have 3 steps to this process. We're going to isolate that squared term. So we're going to get it down to where we just have something squared equals something else. We're going to take the square root of both sides because remember the opposite of squaring something is taking the square root. And then remember for all of these we're going to have 2 solutions just because a negative number and a positive number, if they're the same number, then when you square both of them, you're going to get the same thing. So like negative 3 squared is 9 and positive 3 squared is 9. So we're going to do this first example. So we have x squared equals 64. We see that square term is already isolated. There's nothing added or multiplied on here, so we're good to go. We can just take the square root of both sides. So then this 2 is going to cancel out the square root. So x equals square root of 64, which is 8. And so remember, we're going to get positive or negative 8. Right? Because negative 8 squared equals 64 and positive 8 squared equals 64. So that's going to be our answer for that one. Over here for this next one, we have 3x plus 2 squared equals 27. So now we can't take the square root of this yet because we have this 3 here, right? The squared term, which is this x plus 2, is not yet isolated. So if we have multiplied by 3 and we need to get rid of it, we got to do the opposite. So we're going to divide both sides by 3. So now we have x plus 2 squared equals 27 divided by 3. 3 times 9 equals 27. Now we have that squared term isolated, so we're just going to take the square root of both sides. Boom, boom. So then x plus 2 equals positive or negative 3, because square root of 9 is 3. Now we're going to subtract 2 from both sides, because we have this 2 added. Minus 2. So then x equals negative 2 plus 3, and x equals negative 2 minus 3, which negative 2 plus 3 is 1, and negative 2 minus 3 is negative 5. And these are going to be your 2 answers. Sweet. Next we have 4x plus 10 squared plus 14 equals 26. Now, if you're a little bit confused on what to do first, you can kind of think it like doing PEMDAS backwards. So if we're trying to isolate this term, the last thing we would do in PEMDAS would be adding and subtracting. So when we're solving them, the first thing we got to do is add and subtract, right? So we see this 14 is added, so let's take them off first. So minus 14, 26 minus 14 is going to be, hold on, I just got to bring apart 12. It happens. So we have 12 equals 4 times x plus 10 squared equals, sorry, we're just going to make that a really long equal sign. Perfect. Now we're going to divide both sides by 4 to continue isolating that squared term. So divide by 4. So we have x plus 10 squared equals 3. We're going to take the square root of both sides. Those out, so x plus 10 equals square root of 3. Now, there's no perfect squares that can be taken out as 3, so we're just going to end up with that square root of 3. We don't need to do anything from it. So we're going to subtract 10, so x, remember this positive negative here, so x equals negative 10 plus square root of 3, and x equals negative 10 minus square root of 3. And those are going to be your 2 answers. You can also keep this as x equals negative 10 plus or minus the square root. It just depends how your teacher wants it, or how Delta Math wants it, or how whatever platform you're working on wants it. Okay, so we have one more. So we see this something out here is subtracted, so we're going to isolate this term first by, first of all, adding this to both sides. So we're going to do plus 9. 8 plus 9 is 17 equals 4 x squared minus 16 then we can do 2 things. We can either divide both sides by 4 here, or we can distribute this 4. Because I think the number 17 divided by 4 is kind of gross, I'm going to go ahead and distribute this 4 first. So 4x squared minus 16 times 4 is 64 equals 17. Now let's add 64 to both sides, plus 64. That gives us 81 equals 4x squared. Now we have something a little bit prettier, so let's divide 81 by 4. So x squared equals 81 over 4. And now we can take the square root of it. Now remember, when we have the square root of a fraction, that's just like saying the square root of the top divided by the square root of the bottom, right? So we know that both of these are super pretty perfect squares. So we're going to say x equals positive or negative. Square root of 81 is 9. Square root of 4 is 2. So x equals plus or minus 9 halves. And that is going to be solving quadratics using the square roots. Let me know if you have any other questions. But yeah.